Welcome to qnawire.
Alright guys, we're doing problem 96, chapter 8 in chemistry science. So an important reaction for the conversion of natural gas to other useful hydrocarbons is the conversion of methane to ethane. In practice, this reaction is carried out in the presence of oxygen, which converts the hydrogen produced into water. Use table 8.3 to estimate the delta H for these two reactions. Why is the conversion of ethane to methane, more favorable when oxygen is used? All right, so remember using Hess's law, delta H of reaction is equal to delta H of products minus delta H of reactants. So delta H is going to be equal to 436 plus 1, 2, 3, 4, 5, 6. And I forgot to write one number here. Here, we also have CC interactions. I think I'll just put it down here to make it easier. 348 kilojoules per mole. And we have 6 CH bonds. 15 plus 348 minus 2 times 4 times 413. So this is minus 42 kilojoules per mole. So that's going to be for our first reaction. And for our second reaction, delta H is equal to, 2 times 463 plus 6 times 413 plus 348 minus 2 minus 1/2 times 495 plus 2 times 4 times 413. That's going to equal us, and so that's going to give us a delta H 200.5 kilojoules per mole. Well, so we have the delta H for these two reactions. So when we look at the conversion of of methane to ethane when oxygen is used, is it has to do with the kind of bonds that we're forming. So in this case, so in case A, we're creating ethane and we're creating H2. In this case, we're using methane and oxygen to create ethane and H2O. So H2O is going to have a more electronegative. H2O is going to have a more electronegative. Sorry, I can't talk right now. H2O is going to have a more electronegative. In H2O, oxygen is electronegative and hydrogen is more electropositive. So that creates a polar bond as opposed to HH, which is nonpolar. This will cause us. This means that we're going to deal with a lower energy state. So this H2O bond is going to be lower in energy than this HH bond. So so our product is going to be so that's going to provide more stability to our products. That's going to provide more stability to our products, and that allows the conversion to be more favorable. It also has to do with the molecular mechanism. So here you have two molecules that would be interacting to form ethane, and here the oxygen would be basically facilitating the production of ethane by reacting with our methane. Our oxygen would basically be bringing our two methane molecules together to create ethane. So to some extent, it's acting as a catalyst, even though technically it's not acting as a catalyst because it's being consumed, but it's helping to facilitate the mechanism that is necessary for this reaction to occur.